An enclosed space on a ship is a dangerous place. It is not designed for people to be in it for long periods. These spaces often have very poor airflow. This means fresh air does not get in and bad air does not get out. The entrances and exits are usually small, like a manhole. This makes it difficult to get in and out, especially during an emergency. It is a place where the risk of serious injury or death is very high if you do not follow strict safety rules. We must treat every single enclosed space with extreme caution every single time. There are many types of enclosed spaces on a vessel. Ballast tanks are a very common example. These large tanks hold water to keep the ship stable. Other examples include cargo holds, fuel tanks, freshwater tanks, and chain lockers. Even smaller spaces like cofferdams, void spaces, or the inside of a boiler can be considered enclosed spaces. Any area that is not continuously ventilated and has limited access fits this definition. Identifying that you are dealing with an enclosed space is the first and most critical step in staying safe. We must never underestimate the dangers they hide. The primary danger in these spaces comes from the air you breathe. The atmosphere can be deadly. It might have too little oxygen for you to survive. This is called oxygen deficiency. Rusting steel inside a ballast tank can use up the oxygen in the air, leaving it unsafe for human life. The space could also contain poisonous or flammable gases. These gases might come from cargo residue, rusting metal, or from chemicals used for cleaning. You cannot always see or smell these dangerous gases, which makes them silent killers for any unprepared crew member entering the space. Because of these hidden dangers, strict rules are in place. International regulations and a ship's own safety management system, or SMS, provide clear instructions. Guides like the Code of Safe Working Practices for Merchant Seafarers, or COSWP, give detailed procedures. Before anyone even thinks about opening a manhole, these documents must be read and understood by the entire team. They are not just paperwork, they are lifelines. Following these procedures is not optional. It is a requirement that ensures everyone involved in the operation knows the risks and how to manage them effectively from start to finish. Before any work begins, a thorough risk assessment must be completed. This is not a quick check. It is a detailed process to identify every possible thing that could go wrong. For a ballast tank inspection, you must think about specific hazards. Is the tank coated or uncoated? An uncoated tank has a higher risk of low oxygen due to rust. You must consider the risk of falling from ladders, which may be slippery with mud or water. You also need to think about the structural integrity of the tank itself. The risk assessment forms the foundation of your safety plan, and it must be done with care and attention to detail. The single greatest threat inside a ballast tank is the atmosphere. A lack of oxygen can cause you to pass out in seconds with no warning. Toxic gases like hydrogen sulfide can be present from decaying marine life or bacteria in the mud. These gases can be fatal even in small amounts. Therefore, controlling the atmosphere is our top priority. The first step is ventilation. We must force fresh air into the tank for a long time before entry. This is done using powerful blowers and flexible trunks to push clean air to the very bottom of the space, ensuring all bad air is forced out. After ventilating, we must test the air. Never trust your senses. You must use a calibrated multi-gas detector. This device measures several things at once. It checks the oxygen level, which must be 20.9%. It also checks for flammable gases, which should be near zero. It will also test for toxic gases like carbon monoxide and hydrogen sulfide. Testing must be done from outside the tank first by lowering the detector's probe into the space at different depths. Only when the meter shows safe readings continuously can we consider entry. This testing must continue throughout the entire job. Beyond the air quality, other physical preparations are critical. The area around the manhole must be cordoned off with safety tape or barriers. This prevents unauthorized people from approaching the open tank. Proper lighting is essential. You'll need powerful approved portable lights to see inside the dark tank. Any pipelines or systems connected to the tank must be isolated. This is done using a lockout-tagout or LOTO procedure. Valves are closed and locked, and tags are placed to warn others not to operate them. This prevents anyone from accidentally flooding the tank while a person is inside. Every person involved in the operation must have the correct personal protective equipment, or PPE. This is not negotiable. For a ballast tank, this starts with a hard hat, safety glasses, and a boiler suit. Proper safety footwear with good grip is crucial to prevent slipping on wet or muddy ladders and surfaces. Everyone must also carry a personal gas detector. This device will sound an alarm if the air quality changes for the worse while you are inside. Most importantly, each person entering must carry an emergency escape breathing device, or EEBD. This gives you a limited supply of air to escape if something goes wrong. A safe entry operation requires a dedicated team, and each person has a specific role. First is the person entering the tank. This individual is responsible for doing the inspection. Second is the safety watch, or standby person. This person stays outside the manhole at all times. Their only job is to monitor the person inside, maintain communication, and raise the alarm in an emergency. They must never leave their post. The officer of the watch, or the ship's master, must be fully aware of the operation and give the final permission. Clear communication between all these roles is vital for safety. A comprehensive rescue plan must be in place before the job starts. Hope is not a strategy. You must be prepared for the worst-case scenario. This means having a rescue team on standby, fully trained and ready to act. The rescue equipment must be laid out near the entrance. This includes a tripod or davit for lifting a person out, a harness and lifeline, and full self-contained breathing apparatus, or SCBA, sets for the rescue team. The rescuers must never enter the space without breathing apparatus. Many fatalities happen when would-be rescuers rush in without protection and become victims themselves. The final step before anyone enters the space is a toolbox talk. This is a short, informal meeting held at the worksite. The officer in charge gathers the entire team, the person entering, the safety watch, and the rescue team. They review the risk assessment and the permit to work. They discuss the specific tasks, the known hazards, and the emergency procedures. Everyone confirms their role and responsibilities. This is the last chance to ask questions and make sure every single person understands the plan completely. No entry is permitted until this talk is complete and everyone agrees they can proceed safely. With all preparations complete, the entry can begin. The person entering the tank must follow the plan exactly. They maintain constant communication with the safety watch outside, often using a pre-agreed system of signals or a radio. The safety watch, in turn, keeps a log of entry and exit times and monitors the person inside without any distractions. No one is ever allowed to enter an enclosed space alone or without permission documented on a valid permit to work. If the person inside feels unwell or if any alarm sounds from their gas detector, they must exit immediately. The job stops until the situation is reassessed. If an emergency occurs, the safety watch must not enter the tank. Their first action is to raise the alarm to summon the designated rescue team. The rescue team will then put on their SCBA equipment before starting the rescue operation as planned. Rushing in to help a collapsed colleague without proper breathing gear is a fatal mistake that has led to multiple deaths in a single incident. The rescue plan that was practiced and prepared is the only safe way to respond. The safety of the rescuers is just as important as the person they are trying to help. The alarm and the SCBA are their lifelines. Once the inspection inside the tank is finished, the job is not over. The person must exit the space safely and report to the safety watch. All personnel must be accounted for. The safety watch will log the final exit time. All equipment, such as lights, tools, and ventilation trunks, must be carefully removed from the tank. A final check is made to ensure nothing has been left behind inside. This step is crucial, as forgotten equipment could damage pumps or systems later on. Only when the tank is confirmed to be empty and clear can the manhole cover be closed and secured. The final administrative steps are essential for completing the job properly. The permit to work must be formally closed. This involves the officer in charge signing off on the permit, confirming that the work is complete, all personnel are safe, and the space has been secured. The lockout-tagout devices are removed from the isolated valves. Finally, the team should hold a short debriefing session. This is a chance to discuss what went well and what could be improved for next time. This process of continuous improvement ensures that safety standards remain high for all future enclosed space entries on the vessel.